Hello there. So for the delay, there's been one. Let's see now. I was working on that Polygon thing, and I ran into a little difficulty, so I decided to sleep on it, and that was it was only a couple of days ago. I slept on it. The answer came to me in my sleep as usual, and and so I believe I have it worked out, and the rule certainly works. Now the rule depends on a particular formula, I guess, or a theorem, which sort of states the following. How would one state it? Theorem. Always best to start with the easy part. Theorems are in what color? This color. So given given a line segment and a point, we'll call it just A, B, finite thing. P for point. So we have a line segment AB and somewhere in the plane. Make this big. Where shall I put it? What mode do I want? Lines. Wait. So here's a line. And I should have. I need to have a thing that doesn't get rid of those coordinates. I like to see them. So we'll call this AB. And usually, well, it's not uncommon practice to put a little bar on top. So I put this here. And then some point P. Represented by a dot, which I guess I can use the path thing for. Actually, I want this to be labeled too. Sort of looks right. Then the following is true. Well, actually, I should say. Well, I'll say it now. Give these coordinates x1, x2, or just xy. P is xy, and A, I better give them numbers. I need all of these numbers. So let's say P equals X 0 or 1? 0. And A, which is really a vector from the origin. Whoops. White. And B similarly. Like that. So we'll use 1 and 2 for these. Thought I'd miss up on that, didn't you? No, it was in my mind. There's a boat here. X1, Y1. But anyway, I'll get this one right. One. Do I have 2 spaces? Yeah. Alright. Okay. Now, given these 6 numbers, I can form 2 line segments, basically, like a segment from here to here and from here to here. So I'm going to construct those segments A to P. If we write AP, I'll use capital. Well, it doesn't matter. Equals minus, that's one thing. And A, B we already have. So we actually, that's all I need then. Then the following, which I'll put here. No. So I'm going to write AP as AB as AX, AY. It has an X component and a Y component. just by definition. I have something for that. And AP dx dy. Now I haven't proved this bit yet, but I'm using it. Alright, if we define these things this way, then if the following quantity I don't know what to call it. I call it LR. You'll see in a minute why. Defined to be AXBY minus AYBX A is positive, then P is left of AV. Or B if negative then is right. Whatever left and right means, they're different. And I get a couple bars. Let me see what I mean. I didn't notice it. Actually, if I go back in the path mode, I can get rid of that by making a path no, I can't. And then deleting it. Oh no, what did I just delete? My line. Oh, that's okay, I can recreate that. What else is a function? This. There it goes. Because I was in the line mode. If I was in the path mode, there we go. I don't want to be in any mode. That's there forever, stuck there forever. Alright, so now I have a thing set up that won't do it in this mode, but it'll do it in the Polygon mode. Maybe I'll just save this theorem. Did I hit save? Theorem left, right. Open up my blank. blank empty. Okay, now if I go into Polygon mode, let's say red, you'll see, first I was doing it in that mode, and now I have it in this mode. I have the debug test all set up. If I hit space, it's going to take wherever the cursor is, and given this line segment, to tell me if it's the cursor position is on the left or the right. Watch. So it says that it's to the left of the line segment, and that's correct. If the segment moves from here to here, right, then I have to turn left in order to get to P. If I go over here, it clears it. Now it says it's to the right, and that's true. And now it's saying to the right, and it's going to say to the right until I'm here, say. Now it's to the left. Now I don't know why the theorem works, but I'm trusting it, and I tried it. For instance, if I add more points to this thing, it'll go through all the lines, like here. Left of the indicated segment, that's true. Left of that, it's left of all of them, it turns out. Now if I go here, I'm going to get some left and some right. Left, right, and it's close call, left for this one. We'll make it less of a close call. Left, right, left. See? Now I can make a crazy looking polygon. I didn't leave much space there. Now the fact that it didn't complain means it's discovered that this thing is internally consistent, and it is computed which side is inside and what, because you can't say for sure what's inside and what's outside. I've traced it out here though. It should be up here. It says that the interior side is left. Okay. That is, if we're moving around, the way I click them, the left, any line segment's left side is towards the interior of the object. So if I try to click here, what did I get? And I was holding the control down. Everything said it was outside. The report from every line segment was outside. If I click here, well, you can guess what the report was. Everybody says it was inside. I should only need to check one, but I want to check all and make sure it's internally consistent. And sometimes I will get an assert, but it's pretty rare. So you can see that I can't grab it from places that are outside, but I can grab it from places that are inside. And now let me just show you one where the inside is not to the left, but let's say to the right. One thing, for instance, I thought intuitively, I thought that the first line segment and the last line segment. Well, actually, let me just delete this one. In my head, I was thinking that if you had a polygon, and whichever way you went around, and however crazy it was, right, that if you formed a triangle from the first point and the second and the last point, then and then bisected this line and went halfway from here to there, that you'd be inside the object. That was my intuition told me that. And my intuition was wrong. That's obviously not necessarily true because of this possibility. Well, I could even start it out the way it was. Okay, so it goes like it's going up like that. Now, if I did that, that's an outside point, even though the first 3 points are in exactly the same configuration as before. So the problem then is how to, whoops. Go away. The problem is, how do you find out, get one inside point? And that's where I decided to take a nap on it. It wasn't clear to me how to go about finding an inside point. But then I realized that it's really easy to find an inside point. What you do, see this bounding rectangle? I compute that rectangle first off in order to supply a rect, because this thing derives from a rectangle type object, and I have to initialize the rect to something. So I find the extremes left, top, right, and bottom. And that means that this polygon is entirely contained within this rectangle. And so therefore, if I take, doesn't matter where, but I arbitrarily chose the right, center right plus a little bit. Okay, and now I know that that's an outside point. Then I walk through all of the segments and determine what they come up with for their inside-outside value using the rule. And I decide that that value is outside. And I call that value the winding number. I don't know if it's traced out here. I say interior side, it's right, but the name given for that variable is called winding number. But I know it's not really winding number is some complicated math thingy, but I just want to be cool, you know. Now, why am I not initializing it here to something invalid? It's valid. I hope I'm saying this is terrible. Look, I'm not initializing my variables. No wonder I get in trouble. That's why I like to use a strip for me. This is a good candidate for it. We can put all these. This is a complicated object. I think it has a constructor. It's randomly filled. What does it contain? Other more complicated objects, tens and so on. So, but I could take that out and do what I usually do. Call these mem. M and replace this M with a dot. Are all these things? No, I certainly can't flood fill that with 0 or that. But the rest of these are just regular. This is just actually just a point type. This is an integer value. Winding is valid. That should come first. So what I do then to try, when I add a new variable, I don't have to go running around changing all my constructors. I don't say anything about pen, do I? I just said 0 or M. So if I add a new thing to here, it's going to get zeroed out. For things that are integers or a simple array, like a rect or something, those things don't have virtual function tables or anything like that. Just plain old data. But now I have to change everything. M underscore is valid. Now I can say all and get, B is valid. And I can double check and make sure. See arrow wrong. It's okay. It's easy to find, huh? It's this an arrow again. Well, I should probably do the same with the arrow. Okay, now what's changed here? That, yeah, I took away type, that's correct. Polygon graphic, that's correct. Polygon. See, I called this one. That should have been in the list there. It's just an integer. Serialize. Well, yeah, I haven't changed them all, that's why. Type. Polygon, yes. Polygon. I can actually, now that I can do binary, I can serialize that whole M in one go. What's next? Sorry, I'll pause this and just complete this. Okay, all done. Yeah, repairs that problem. As far as the other members, the pen is, you always have to supply something to say what kind of pen to use. The brush might never be used. Like if it's not going to be filled, then you don't need a brush. If you pass in a brush, then it's obvious that you do want it to be filled. Now what I'm doing with the point in object is not depending, right now I'm not checking to see if it's a filled or non-filled object, but now I should change that. Point in object, which is the function I just wrote. I can show you how I wrote it. Actually, it's identical really to this check validity. See, here's the point. Here's the thing. Now I had to take this line away to debug it because I have the coordinates in Cartesian coordinates, right? And it's walking through the segments and everything's shifted, and so I just took that out temporarily. And then I compute an outside point. I just take a point that is the right side of my rect, add a bit, and I just take the central y. It doesn't matter. Any point outside will do. I took that one because it was easy for me to debug, because I have that thing, right? My little debugger thing. I can verify that it's working correctly. I can do that, or walk around, see that it's left or right, and so on, and what answers I should be getting. It's harder to tell at this point, but I never debugged it at this point. I mean, I'd hit enter, right? But by that time, it won't have erased all those coordinates, which is good, or drawn the last line. It checks this, does this validity check first. Now, what I did, or what I have here, is now this thing contains a new type of object, called a point set. I mean, I had this point set, but I made it a global thing. Now it's part of. This is in CS Windows H, and then so if it's used, I've used this thing point set in capitals, and if you're using this kind of point, I can type that to have this name, and this has this name. This thing contains a point set, so that's integer TS points, no doubles. Pen, a brush, pen for the border, brush for the fill, and these types. Hollow, filled, or framed. Framed would mean something that is filled, and it might have a different color border, let's say. And it's also thicker. If a thing is not framed, even if the pen and brush are the same color, it'll be smaller in size, because just like with rectangles, you won't get the border drawn, and so the rectangle is smaller. And this thing that I've called winding, essentially, which tells you if you, as you're moving through from point 1 to the last point, whether or not you're going left or right, right? or let's say counterclockwise or clockwise. If you're going counterclockwise, then the inside is always to your left. If in the other direction, is that true? Yeah. No. Maybe it is true. Can I go count? Oh, it's running. Can I go? Oh no. What did I just do? Look at all that, just for this stupid dialogue. I know I chose nothing. If I go is it possible for me to go in a clockwise manner and have the inside to my right? Well, it is sort of, because you could do this. So for a minute you're going clockwise, right? This is clockwise direction, sort of, but the inside is to my right. And now it's, sorry, counterclockwise. But then now it's going clockwise. Now, is it going to figure this one out? It seems to be fine. It doesn't care, clockwise or not. The interior side is the same for every line segment. Doesn't matter which way you go. In this case, it happens to be on the right, and that's what that thing, the debug trace, should have pointed out. Yeah, interior side is right. Maybe I'll put a character turn there. It's hard to read it. Or get rid of this bit. So any point, if you're moving along this particular polygon, your direction of motion is as the points were given in the construction, and the points were given are, always given in a way that there is a direction of motion, or a direction that you're going. And so here, if I run my thing, oh, it's good. I've moved it, so make a new one. How did that go again? The debug thing doesn't do the computation inside outside. It just tells me if a line and a point aligns to the left or right. Now it should sync up with this. No, it's okay. I gotta choose a point. So left of that, left, left, right, right. It's going to be right for all of these. Inside, as far as these ones are concerned, right, and now it's back to the one that should have got deleted. How do I get rid of it again? How do I clear that out? When I choose a color. Oh, wait, yeah. No. Now it should be okay. Okay, so I could select this point and check to see if it's to the right or left of all of those various line segments. And that's all there was to doing it, really. Finding an outside point, walking around. So I would find an outside. I'm going to the beginning. First point was next. I'd take this as the outside point. Initially compute the left or rightness as far as the first segment goes. Okay. Then what I'd do is I'd go to the next segment, see if it's left or right of that segment, and then see how many sides it intersects. This one it says to the right of that segment, and there's one intersection. So therefore, outside for that line is right plus one intersection. Okay. And then that's taken as a definition. That right plus odd intersections is outside. That's now been defined. This here says right, so one intersection is good, it's consistent. Right, again, consistent. Right, consistent. Now it's left. It would be consistent if and only if there are an even number of intersections, which there are. Same here. It's to the right of this, so it expects an odd number of intersections. To the left, now there should be an even number of intersections. There are two. To the right, it should expect an odd number of intersections, and there are either one or three, depending on where I take it. I take it from the center. I take the center point of the line segment and compute from there. Again, right, so there should be an odd number of intersections. And let's see, 1, 2, 3, if it's there. It would be very bad if it wound up on this line, right? Because then you would get a contradiction. I don't know how to deal with that problem. If it so happens that it winds up on a line, right? Then the line from here to here does intersect this line, but it's also parallel to it. I could use that parallel thing, right? If a line intersects and not parallel, then count it. But if it's parallel, then don't count it. Okay, right again should be odd. Right, odd. Left, there should be an even number of crossings. 1, 2, 3, 4. Actually, it's more this way. 1, 2, 3, 4. Right again should be an even, left, odd, and so on. And as you can see, it works. I might get into an assertion if I click one of these coins, but it's not that bad. The worst thing that happens is that you have to click again. So that's the algorithm to look at it. First, I go through the point set which is just an array of points and a color. Well, here I'm just tracing it out because I had a bug. What was happening was I was getting double clicks, like 2 clicks in a row very, very rapidly, which would give me 2 identical points, and the thing would assert on me. And it happened quite often because there's something wrong with my mouse. So I added some time handling in my click detection. If the time elapsed between clicks is less than half a second, then I don't count it. Okay, so then I go through those points again, creating I vectors from one point to the next. Okay, the reason for this modulo thing is because of the +1, which only counts for the last one, and that brings you back to the 0th point again. So when this is get size -1, this is get size, so that gives you m point of 0. Then it's a matter of going through and following the special theorem. Here, 1O means segment 1 to outside point. D vector is just a point, but it's a different type. And the reason I invented a new type that's exactly the same as another type is for things like something that uses it. Here, straight line, okay, takes a point and a vector. Now, it could also take 2 points. And how would you know the difference if this is taking an end point, 2 endpoints to make a line, or a point and a direction? And the way to do that is to create a new type which has a different name, even though internally it's a point, and to make to require an explicit cast from the thing that it's actually derived from. So I have to, if I put in 2 points, it'll complain, and that will alert me to the fact that one thing's a position and the other is a direction, which is different. Directions are differences, right? Like deltas. Okay. And that's why you see I've used D vector for these differences. I take the midpoint of this given segment and create a direction vector towards that point. And then I do the magic unproven, as yet unproven, left or right calculation, which is that theorem that's got to be proved. And now I walk through all of the others. So going through the list of segments that I just created, the next 2 points are the 0 and 1 points that make up a segment. And now I use this magic function that I created that uses my wacky mechanism here. No, not the other one, but this thing with the coordinate transformation, just for fun. And if there's an intersection between the point from the outside point and the segment I've chosen and another segment, then I just bump up this value. If the value happens to be odd, And if I haven't yet determined the inside sign, I just assign it. Otherwise, if the assignment of the inside direction changes, then I have an invalid. Something is incorrect and invalid. Which this should be assigning, and there shouldn't be any change from the initial. Similarly, if it's negative, if it's a even number of intersections, then the inside side is the negative of the left-right from the magic formula. And if everything comes out consistent, then I conclude that it's a success, and the interior side is given by, if this is -1, the right side, or +1, the left side. And that's all there is to it. Point in object is essentially almost a copy of that. I only really need to check one, but I want to make sure that everything is still consistent. There's no check for consistency on the interior points, right? Now, I don't need, this is one case should be only for the solid objects. For the hollow objects, it should be walk through all the line segments and just do a distance check from the line segments, which is what I used to have. Not sure how long ago. So I have to redo it to put that back. Point in object. Okay. This is not. Wait, that's source control. Okay. It's not far enough back. Just gotta grab the old code. If hollow, so I need this code. Distance to line, okay. And that should be it. And there you go, that's how you do a polygon. And this is no longer a to-do. That's how you find out the inside, if something's inside or outside of a polygon of any kind of any shape, as long as it's connected. Not too many brackets. Oops. Now why is that? No. No, that's funny. That's a for loop. That's the else, okay. And I should be returning here, right? Return true, and this should return false. There, I believe that does it. Again, here I'm using iVector is so useful. Right? It makes all the time. The zero, it's got intersecting and the distance. This thing accepts it. Oh yeah. What's the number? That's number gone. I don't need to do that. I can put that in there. Just doesn't cost any time. The optimizer will change that into a literal number. That's it. Okay, just thought I'd show you that it's possible and it can be done. And now I still gotta prove that theorem. I'm gonna get to that post haste. See you next time.